y equals to 6x positive 18. One of the equations in a system of two linear equations is given. The system has no solution. Which equation could be the second equation in the system? Okay, so in the system of two linear equations, one of the linear equations is given, that is y equals to 6x positive 18, and we have to find the other linear equation so that the system has no solution. Okay, here the given equation is in slope intercept form, but for the other equation we have to go to the options where in each option we have the linear equation in standard form. That is, we have x term or y term on the left side and constant on the other side in each equation. So better we can write the given equation in standard form. That is, we have to get the x term and y term on the left side and constant on the other side. So let's subtract 6x from both sides. When I do so, this positive 6x, negative 6x will cancel out. So on the left side, I'm getting negative 6x positive y equals to 18. So now I got the given equation in standard form. That is x term and y term on the left side, constant on the other side. Okay, so if a system of two linear equations has no solution and the equations are written in standard form, then the coefficient of x and coefficients of y in both the equations must be same and they must differ in constant term. So for example, here I have the one of the two linear equations. So I have to get the other linear equation so that the system will not have a solution. So what can be the other equation in standard form? It has to be negative 6x and positive y. So that means the other equation must have the same coefficient of x. That is, whatever coefficient we have for x in the given equation, the same coefficient we must have for x in the other equation. And the coefficient of y also. So whatever coefficient we have for y in the given equation, the same coefficient we have for y in the second equation. And the constant term in the given equation is 18, but in the other equation, the constant term should be different from the one what we have. That is, it should not be 18. It has to be some other value. So let's say the constant is k, but this k should not be equal to 18. So here, this system has no solution. So in this system of two linear equations, both the equations are in standard form. So in both the equations, we have the same coefficients for x and same coefficients for y, and the constants are different. Here we have 18, and here I do not know the constant, but it should not be 18. It has to be other than 18. Okay, so keep this stuff in our mind. Let's check the options one by one. So definitely option C and option D cannot be correct. So because in option C and option D, we have the coefficient negative 12, coefficients of x negative 12 and coefficients of y positive 1. But according to the condition we have discussed over here, the coefficient of x in the other equation must be negative 6. I mean the coefficient of x, and the coefficient of y has to be positive 1. Okay, so let's in option A and option B. So we have the coefficients. The coefficient of x is negative 6 and the coefficient of y is positive 1. So either option A or option D can be correct. Option B can be correct. But in option A, we have 18. But according to the condition we have discussed over here, the constant term in the second equation should not be 18. So it should not be same as the constant we have in the first equation. So we can reject option A. So option B is the correct answer choice for this question. So because a system which contains the two equations, negative 6x positive y equals to 18. This is a given equation. And let's write the equation we have in option B, that is negative 6x positive y equals to 22. So the system contains these two linear equations, has no solutions because we have the same coefficients for x, same coefficients for y, and we have different constants. So the correct answer choice for this question is option B.